All right, in the third part of this little series on loops, I'm going to be talking about for each loops. So, first video we talked about loops in general, then kind of dove into um, while loops, and then from there we were talking about for loops. So we showed how you can convert a while loop that does counting into a for loop, which is, in my opinion, like really designed for counting. I demonstrate or I talk about at least how you can do like fancier things with a for loop, but I don't really recommend it because it makes it harder to read. So if you need something a little fancier, like I would recommend using a while loop and making it readable that way. But the third one that we didn't get around to is a for each loop. So I wanted to talk about what you might use a for each loop for, and I want to be able to show like how you might use a for loop and how we can make it a little bit more readable by switching to a for each loop. So again, this is for people that are new to programming. We're going to be using C sharp. So if you're using something like Python, C++, or another programming language, concepts are probably very similar. Many languages have something like a for each loop, talked about in the other videos, a while loop, a for loop, but the syntax that you're using in those languages might look a little bit different. The idea, the concept is probably like very much the same, so it's worth talking about. If it makes sense and looks okay to you in C sharp, great. But if you're like, okay, well, I don't really get the syntax, it might be worth, checking out another video or other programming guides. You can see in the language that you're interested in what it looks like. Okay, so that was a lot of rambling. Let's actually dive into some code here. So I still have up some of the old code that we had from the other two videos. And the last thing we were talking about was a counting for loop that prints out hello world with a count. So a for each loop, I touched on it at the end of the last video. It's essentially a way that it lets you iterate through a collection of things. So we haven't really been doing that in these examples. So I want to show you how we might iterate through a collection with a for loop, and then how we can make that more readable, in my opinion at least, with a for each loop. So let's start by actually making a collection of things. This isn't really the important part of the video, so let's I gotta show you with something. So let's make a array. Let's call it I don't know, items, because it'll be the items that we're going to. Let's actually call items to iterate. Okay. Um, and we are going to make a new string array. So an array, again, I should touch a little bit on this. An array in C sharp and other languages is it's what you call like a primitive collection of things. So it is a data structure. We won't dive into that, but it allows us to have multiple strings, and a string in this case is something like a word or a series of words. So hello world is a string, so we could put hello here. We could put world here. Then we could put an empty string. We can see what that looks like. We could do something that says this or these are our strings. And then maybe we'll finish it off like this. So this is just what we've done is we've declared a string array called items to iterate, and we're like newing up, so we're instantiating a new array. If you've never programmed before, I might be using some words where you're like new, like instantiate. What does all this mean? Declare. Don't worry, it's not really the important part of this video. But what this has allowed us to do is make conceptually a collection of words. So in this collection, we have one word that's hello, one word that's world. We have a blank word, right? So it's just an empty string. So we can see what does that look like when we're doing our iteration. Then we have these are our strings, and then we have a single exclamation mark as another entry. So in this, we have 1, 2, 3, 4, 5, 6, 7, 8 items in our array. So there's 8 strings in the array. So if the goal that we want was to print out all these things, just to be able to show you, if we weren't using loops, you could, and I like this, I wouldn't recommend doing it, but if you didn't have access to writing out this code using a loop, you might have to write something like this, where you go debug write line, and you're taking the first, so the 0 index, which is what this is, thing inside of items to iterate, which would be hello. And then you might say we'll take the thing at position 1. So because in most programming languages like C#, things are 0 indexed. This is index 0. This is index 1. The empty string is at index 2. Then you might have 3. And you would do this. I said there were 1, 2, 3, 4, 5, 6, 7, 8 items. So we would go all the way up to index 7, because index 7 is the 8th item, because we started at 0, right? So just to double check, 0, 1, 2, 3, 4, 5, 6, and 7. So if you couldn't write out a loop, you might, write code that looks like this, which is not great, but it will work. Okay, so how do we make this better? And how can we use something like a loop? Well, if we look at what we had before, I'm going to change this from count to something, another variable name that will make this a little bit more intuitive. So we're going to be talking about the index we want to use. And I can get rid of all these lines of code just by doing this. Okay, so I'm going to change this in a second, so give me one sec. So instead of writing out this copy-pasted line of code and all we're doing is changing this index, we can let the loop do that for us. Now, there's one thing wrong with the loop. Maybe there's more than one thing, but one thing I can see right now at least is that it's not 5. We're not looping 5 times. We said that we're going to go 0, 1, 2, 3, 4, 5. There's 7 indices. So we want to loop while the index is less than 8. Right? Because once it reaches 8, there's no more things. We can't do it. But at 7, that's our last one, which is here. So this is one way we can do it. And if you don't like how every time I keep counting these out loud so I don't mess it up, because I am streaming this live, a safer way to do that, and I would recommend doing this in your code so that you don't accidentally do this, and your code is now broken, you actually have the ability to ask your array, or the collection you're working with generally, a length or a count of items in it. Okay? So I can go take that one out, and I don't have to change my loop condition because length is now going to be 8. And if I put it back in, oops, I guess, there we go. If I put it back in, now there's 9 things. So it knows because it's dynamically asking for the length of the array. Okay? That's a little bit safer way to do it. And let's go ahead and try this out. So what we should probably see is, instead of down here saying hello world with these counts, we should be able to see all of these strings. And some interesting ones will be, we have after hello world, we should have a blank line because we're printing out a new line that is empty, right? So there should be an empty line. And the last one is just an exclamation mark. So hopefully we see that. And moment of truth. It looks like it worked. So it says hello world, then we have the blank line like we talked about, right? And then from there, we see these are our strings and the exclamation mark at the end, right? So that whole highlighted block is that highlighting? Yeah, it is. Just making sure it's recording in the stream there. So yeah, that would be how we could do this iteration with a for loop. But this video is about for each loops. So in this particular case, we happen to be using counting to accomplish the job we want to do, right? We're counting from index 0 all the way up to the last index that we can address. But it means that we have to write something that looks like this to count all the indices that we're interested in. Now, if you're interested in just iterating through all the things, we don't have to necessarily count. We can use a for each loop to do that for us. If you were interested in counting and maybe only iterating and picking specific ones, so maybe all the even ones, you could basically change this for loop to do that for you. However, there's a nicer way that we can make this loop look. So we can do for each, and then we can say string item in items. Oh, I didn't call it that. I called it items to iterate. There we go. So that will work, and then we get rid of that, and there we go. So this is, in my opinion, way more readable code. You got rid of a whole variable that you're using as an index. You're not doing an indexing operation where maybe someone might have a typo or something when they're coming through. It's less code, right? So the way this reads is for each, and then it's saying for each item in items to iterate, go do this body of the loop, right? So it's essentially just like the last one. We don't have access to an index anymore, but we don't need it because it kind of does that indexing for us on here. So if, for example, you did need to know the index you were working with, so if we wanted to print out on every line the actual count or the actual index that we were at, you may want to use a for loop. The other way around that is you could reintroduce a counting variable here. At that point, you might as well go back to a for loop. However, what we've done, like I mentioned, is just kind of reduce the syntax on the for loop line that had the counting variable, the termination condition, just to be, give me each item inside of this collection. So if I run this again, hopefully it looks the exact same in the output. And there we go. You can see hello world, empty line. These are our strings with the exclamation mark at the end. So again, just an easier way to print that out. So what else is worth mentioning about for each loops? The way this loop is designed with this syntax, if we wanted to stop early, so if I said, okay, let's only print to the 4th index, so print everything up to and including the 4th index, we can't really do that in here. You can write some extra code to try and do that for you. So you could say, if you've reached the item that equals items to iterate at index 5, which would be the one we don't want to see, then you could exit the loop. But that can get a little bit messy. That's where I might suggest, if you need to have more control over your termination and you're not trying to just go through everything inside of your collection, I might suggest going back to a for loop or a while loop where you can write some more termination conditions or conditions that you want to keep looping on. Just because, and maybe I'll just show you a quick example. So if we said we want to stop, so I said this is 0, 1, 2, 3, and 4. So we want to write out everything up to and including the 4th index. So what we would say is, this is something we haven't covered yet, which is a way to break out of loops, which is using the keyword break. So we could say if item, and this isn't necessarily how I would recommend coding probably anything with string comparisons and loops and termination conditions. However, this will work for our example. Our OUR is the 5th item, right? So if we've reached that, we can break out early, right? If you wanted to make this a little bit more dynamic, instead of putting the word hour in here, you could do at index 5, because I did say up to and including index 4. So once we reach index 5, right? So once the item is the same thing at index 5, let's break out. So again, it's a little bit of code. There's a few things about this that I don't like, and I'll give you a counter example right after we run this. Right, so hello world with the empty line. These are, and then it never prints out our, because once we reach it, we break out. Okay, so why don't I like this? Well, okay, what happens now? All right, if the whole goal was to print up to and including index 4, if I go run this now, it's only going to print out hello, right? So because I contrived the example, we could make it work and we could break it very easily. But this is the exact reason why in like real production code, I'd recommend not trying to find ways to terminate like this. Like if you truly wanted to only do the first 4 things, or sorry, yeah, I guess it would be first 5 things if you're including index 4, then I would recommend that you're using something like a counter or a cleaner way to do your termination, because doing a string comparison like this to check, unless you're absolutely positive with your inputs, which is probably pretty rare in most real programming situations, I'd say that you might want to avoid this kind of thing. So that was a way to break out. You can use that break inside of a for loop as well as a while loop. So we've just shown it inside of a for each loop. And another thing you can do is called continue. So I might as well touch on that very quickly. You can use continue again inside of your for loops, inside of your for each loops, and inside of your while loops. Continue will basically, once that line of code is hit that says continue, so this line, it will go back to the top of the loop. So if I run this, it should do nothing. I mean, it should look like it does nothing, right? So there's no output that it printed that say any of these strings, because every time we entered the loop, so it would enter the loop and say item is currently hello, let's just continue. Next iteration, item is currently world, let's just continue. Next iteration, item is currently empty, just continue, and so on. So it never actually does anything. I think that is mostly what I wanted to cover. So that, just to recap quickly, we did just talk about breaking and continuing, right? And those apply to all the different loops that we talked about. That was a little bit of bonus information. We talked about for each loops, which allow some really concise way to iterate through collections of things, which is really nice. I guess before I go summarize for loops and while loops again, another nice thing about a for each loop, it's a little bit more advanced when you start to get into something called enumerables versus a collection. So in a collection, you are able to index into things. I guess that might be more of a list. So let's just do this. This is actually going to be a much better example to kind of show you some limitations, I guess, that you can run into when you're trying to use different loop types with your different collections. Okay, so let's do, I'm just going to write, just like the previous example we had. Okay. So we used to have something that looked just like this one, and it's because we're dealing with an array we can do that, okay? An array lets you index into certain positions. If I made the type of this a I read-only collection of strings, can we do that? No. So if I made this count, because a read-only collection does not have a length property, it has a count property. But you can see items to iterate at index I now has a squiggly underneath it. It's saying you can't do that. And the error is that it says it cannot apply indexing to this type, because a collection lets you enumerate and it lets you have a count. But if you notice, we're still able to use a for each loop, which is really nice. And if we had a I read only list, I'm saying this out a little bit more advanced, but like you might want to follow up on some of these things for collections and enumerables later. An I read only list does let us use count, and it lets us use a for each loop, because a list does allow indexing. So that's great. And an I enumerable is sort of like the most, I want to call it the most basic interface that those types have. So an I read only collection, or an I collection, and an I read only list, or an I list, all of those are I enumerables. So you can always use a for each loop on them. You can always iterate through them. But an I enumerable does not have a count on it, and it does not have an index on it. Okay, so if someone had a return type of a method and it said, here's an I enumerable of strings or an I enumerable of objects, you cannot count and you cannot index with that. You are basically stuck with this. You need to use a for each loop to iterate through it. There's a few more advanced exceptions to that, but like the syntax that you would want to be using is a for each loop. So again, if you're dealing with I enumerables, lists, or collections, your ability to use a for loop to count through might change. Whereas if your only goal was to just enumerate through those things and iterate each item, then you can get away with a for each loop in all of those cases. Okay? So that was just a little bit of extra for each loops and some advantages to using them. For loops came before that. That was really our basic way to do counting. It's really loop syntax designed for counting. It can do other things, but really recommend it just for counting. And then your do while loop is really sort of your most flexible looping mechanism, where you can write an expression for when you want to keep looping. So you can write counting loops in that, you can write loops that go forever in that, and you can have a whole expression that's like why you want to keep looping. So a few different variations, a few different examples kind of showing you some transition between each of those types of loops, and hopefully that's helpful. Yeah, I think that's probably it. There's more things you can do with loops, but I think for the basics that probably covers it. And I've kind of mentioned it a few times through these videos. These concepts, while I've shown it in C#, they are definitely applicable to other programming languages. There might be little slight differences in the syntax or slight differences in when parts of the loop conditions are checked and that kind of thing. But for the most part, that should be pretty much the same. So thanks for watching, and hopefully that was helpful.